Good afternoon, everyone. I hope I am audible and visible both. Are you getting my transmission? Everyone, I am good. Manish, Saurabh, are you getting my reception? Good afternoon, Smita. I hope this. Good afternoon, Namrata. So, see, so as I got requests from so many people to WhatsApp for the sharing of the PPT. So, I have already shared my earlier PPTs, and I hope uh, this has already been uploaded on the mobile application. This the PPTs of the previous four lectures. The PPTs of previous four lectures already I have shared. So I hope all of you must have received PPTs. So please confirm me whether you got PPTs or not. You got PPTs of previous lectures or not? Yes, right. So it is already confirmed by Sweetie. Yes, it is already uploaded. Fine. Good. So right. Anyway, right. Okay, fine. So I hope that you all are comfortable. Fine. So listen, the last discussion was, see, the last discussion was all about what we have done in the previous lecture. Uh, the last discussion was all about chromosome, sexual determination, and AI, right? Related with the surrogacy as well as IVF. This we have done in last lecture. Hi, good evening, Asif Ali. Sorry. Okay, fine. I have changed the dimension of the camera. Sorry, I have changed the dimensions. Just hold it. So this part is the camera side, I hope this is the camera side. I'm simply mentioning here. This is the camera side. You're getting my picture here. So, okay, right. Yeah, yeah. I have mentioned here. My face must be here. This is the camera or the face side. Fine. So what we have mentioned here, what I have mentioned here, it's all about the topics that we have done. We have done in the last lecture. And we have done in the last lecture, and this was all about the chromosome, the sexual determination, artificial reproductive technology, and under this artificial reproductive technology, we have discussed a lot like the IVF, uh, and the rest of the discussion we have done. See, in the same continuation, I told you this chromosome, chromosome, chromosome is gene carrier. Chromosome is gene carrier. Chromosome is gene carrier, right? And the function of the gene is what? To control characteristics. Characteristics. The function of the gene is to control characteristics, right? Okay. Like if you just look at the structure, like here, see here the structure like this. This is the chromosome, and that chromosome consists of a number of gene sequences, and these gene sequences are responsible for characteristics. Responsible for characteristics. Right? So these characteristics could be non-sexual, or this could be sexual. This could be non-sexual, and this could be non-sexual and sexual. Right? This could be non-sexual and sexual. Manav Sekhari is asking about what is chromatid. Fine. This entire structure is Manav. As you can see here, this entire structure is the chromosome. And the chromosome usually exists, right, in the bivalent form like this. This entire structure is chromosome. This entire structure is chromosome, which exists in the bivalent form, and this monovalent form of this chromosome is what? It's a chromatid. Chromatid. So these two are, as a whole, these two are chromatids, and as a whole, this entire structure is chromosome. Fine. I hope you got my point, Mano. Fine. So the point is that chromosome controls characteristics, and these characteristics could be non-sexual. This could be sexual. This could be non-sexual. Ritik, what else we have to study along with your class for this exam? Listen, Anna, we are going to discuss everything which is required for this year of the exam. Fine, so just hold it. Clear? So see, the point is that if I talk about this chromosome, if I talk about this chromosome, is chromosome. This chromosome controls normal characteristics as well as this chromosome also controls genetic disorders. Genetic disorders. Fine. So when we talk about the genetic disorders in this category, we have so many examples like diabetes type 1 is a classical example. Type 1 is classical example, while this type 2 is lifestyle. Lifestyle. Type 2 is, I'm not writing, listen. Well, I'm not writing, I'm simply leaving this part. So fine, I'm just mentioning here, it's a normal characteristics. This controls normal characteristics and this controls genetic disorder. Right? So I'm just talking about, the first of all, I'm just talking about the genetic disorders. See here, genetic disorders like here, the classical example of the genetic disorder is what? It's the diabetes. Okay. Again, the classical example of the genetic disorder, this could be hemophilia. Hemophilia. Hemophilia is blood related disease. And this is, it's a list of genetic disorder. Chromosome controls normal characteristics as well as genetic disorder. And in the category of genetic disorder, I'm just mentioning here, this first is the diabetes, second as a hemophilia, this third as a color blindness, and this is vision defect, this fourth as a one more example, this fourth as a sickle cell anemia, etc. Sickle cell anemia, ANEMIA. So these are the classical example of genetic disorders that we have mentioned here. And apart from this, chromosome consists of gene, and the gene controls all characteristics. And when we talk about normal characteristics, so here the classical example of the normal characteristics would be this would be height. Yes, this would be the skin color, and this would be all non-sexual and sexual characteristics. Non-sexual and the sexual characteristics, and in this category we need to discuss about one classical example. That is what? It's a blood. It's a blood, and the blood is non-sexual characteristics. Blood is non-sexual characteristics. Blood is non-sexual characteristics. Right? Fine. So let me take here the one classical example as a blood. Let me take here one classical example as a blood. I'm going to elaborate this blood. Classical example as a blood. Right? So when we talk about this blood, when we talk about this blood, when we talk about this blood, we need to discuss about. One is we need to discuss about genetics of blood, right? And again, chemistry of the blood. We need to discuss about the genetics of the blood, and in this genetics of the blood, we need to discuss about ABO blood blood group determination first, and the second is IH factor. The second is IH factor. Rohisha, here, what happens in the case of transgender? Rohisha, one of the classical example of the transgender already we have discussed in the case of the Klinefelter syndrome. So we are not going to discuss anymore. If you want to see one example, to some extent, a short, brief introduction, the brief discussion regarding this transgender, we have just discussed in the case of the genetic syndrome, like where we have discussed about the transgender, where male is the male with the female character, right? So I'm not going to repeat anymore. This is the lecture number 3. We just go through the application. It is already uploaded as a backup and go through this. Fine? Okay. So one is what? It's the genetics. We need to discuss about the genetics of the blood as a ABO blood group, and the second is the IS factor, and then we should also go for the chemistry of the blood. We should also go for the chemistry of the blood, and that will make a completion of the discussion what we are talking about. Okay, right? So let me take one by one. Let me take one by one. Like the first is the genetics of the blood, and the second is chemistry of the. One is the genetics of the blood, and the second is the chemistry of the. Yes. So I am going to take one by one. I am going to take one by one. This first is the genetics, and the second is chemistry of the blood. And after doing this, can you see? Can you see this screen? Dear students, you cannot see my face, but can you see this screen? Can you hear me? Can you see this screen? No, 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 no. Yes. Then I'm going to take the one example as a. I am going to take here. Okay, right, fine. So this is genetics of ABO blood group, right? Genetics of ABO blood group. Fine. So when we talk about the genetics of the ABO blood group, this ABO blood group is controlled by controlled by gene I, gene I, and the gene I, and this gene has three forms: IA, IB, IO. Right? There are three forms of the gene I. There are three forms of the gene I. There are three forms of the gene I. This gene I has three forms. One form is IA, second form is IB, and third form is IO. Third form is the IO. Fine. Okay. Now, this IA form is dominant. It is dominant. Dominant, and this controls blood group A. Blood group A. Are you getting my instruction or not? Please. Dear students, can you see this screen or not? Dear students, can you see this screen or not? Dear students, can you see this screen? Yeah, right. So this see what we have mentioned here. This ABO blood group, ABO blood group, hmm? ABO blood group. This ABO blood group is controlled by gene I. Yes, and the gene I has three forms. One form is the IA, which is dominant. DOMI means dominant, and this is responsible for blood group A. This I, the second form is the IB form. This is the IB form of the gene, and the IB form of the gene is also dominant, and this is responsible for the blood group B. While IO form of the gene is recessive. Recessive, recessive, and this controls blood group O. Right? Blood group O. So here we have simply used two terms. The term number one is dominant, and the term number second is recessive. Dominant means visible or expressible. Hidden means recessive means hidden form. HIDDEN. HIDDEN. It's hidden form or non expressible form. Non expressible form. Right? Non expressible form. Okay? Yes, fine. Then can we go ahead? So what I have discussed here, blood group, blood group ABO. Blood group ABO. This blood group is controlled by gene I. This gene I exists in the alternative forms. Fine. IA form is dominant, IB form is also dominant, and IO form is recessive. IA form is responsible for blood group A. IA form is responsible for the determination of the blood group B, while while IO form is recessive form, and this is responsible for the blood group O. Right? Everyone is getting my reception properly. Everyone is getting my reception properly, except the few people. Right? Except the few people. I asked this question, and everyone is responding like the audio and the visual signal is proper. Except couple of miss 2 or 3. Like Abhyas. Otherwise, everyone is responding like the video, audio, and visible. Lovepreet, yes. Fine. Ayush, yes. Sushant, yes. Everyone is saying yes. They are getting my audio and visual signal properly. Please confirm me whether you are getting my. If you are getting my audio and visual signal, please let me know. Please refresh your application. Please refresh your application. Please refresh your application. Please, all requesting everyone, please refresh your application. I'm just waiting for response. Unless you are going to get the proper audio and visual reception, I am not going to carry on. Vinod M. Patil is implying that audio and the visual signals are visible. Right? Varsha is also responding that getting reception properly. Please, the rest of the students, please let me know whether you are getting my reception properly or not. Now see, now everything is fine. As per the response of the students, now they are getting reception properly. Right. So again, let me repeat once again. What I right, Sadhana, Prashant. Okay, right. So what I said here, what I told here, Prashant, thank you. Thank everyone. Balla, getting proper. Okay, Maria. So the rest of the students requesting everyone, please refresh your application because most of the people they started getting the reception properly. So please requesting everyone, just refresh the application. Right. So what I said here, okay, right. So now I am continuing. What I discussed here, now the blood group is the best example of the non-sexual character, and the blood group is controlled by gene, and the gene, this particular gene exists in three forms, and out of three forms, two forms are dominant forms, expressible form, while the third form is recessive form. Means usually it is hidden or non-expressible form. Hidden or non-expressible form. Means this non-expressible or the hidden form is going to hide itself when it comes with dominant form. When it comes with the dominant form, right? Is a clear that is the clear definition of recessive. Means, right, if place is occupied by both dominant and the recessive form, the expression of the dominant form is visible. Means the point is that if IA and IO both are coming together, if IA and the IO both are coming together, so this form will express itself because it is dominant form, and here the blood group will be A, while this form is what? Recessive form, and this form is hidden form. This form is the hidden form. Right? Fine. So just taking this page, this discussion on the next page, right? And see, this is probably my picture area. Right? Now, see, when we talk about this blood group as A, it must have allele as a IA or this could be IO. We are talking about the allele possibilities. Allele possibilities. So for the blood group A, the maximum possibility, the maximum possibility this would be IA and IO, where this IA form is where this IA form is dominant form, while this IO is recessive form. Right? For the blood group B, there must be allelic form as a IB and IO. Why? Because this IB form is dominant form and the IO form is recessive form. Right? For the blood group A, here must be allelic form as a IA and IB. Both are dominant. Both are dominant. So the AB is the best example of. AB is the best example of. The blood group AB is best example of co-dominance. 50-50% of the dominance. Co-dominance means 50% its dominance and the 50% this dominance, because this is also dominant and this is also dominant. Both forms are dominant. Clear? So see, the blood group AB is the classical example of codominance. Blood group is the best example of the codominance. Okay, and the next blood group is the O blood group, and for the O blood group there must be gene like IO, because if IO is coming with the IA, so the blood group, the nature of blood group will be A blood group. If IO is coming with the IB, so the nature of blood group will be B blood group. So for being O blood group, there must be IO allele in isolated manner. That is what that make a sense and the existence of the blood group O. So this is what it's a blood group and possibilities of allele. Possibilities of allele. I am just applying and just how this blood is determined. How this blood group is determined. So let me take here the one classical example how this blood group is determined here. I am just taking this example here. This is example number, right here. Mother blood group is A and father is also A. So what blood group can be possible in next generation? So again, we are talking about the possibilities. So for being blood group A, there must be the involvement of possibilities of the allele as the IA and the IO. Yes. So in this case, in this first case here, the possibility of the allele, here, so IA type, IO type. For the A, possibility of the allele, IO type, IA type, yes. IA type, IO type. Make a cross. We are going to see when this IA cross with this one. So the result is what? It's a IA. When this cross with this, the result is IA. When this cross with this, the result is IA. And finally, this cross with this, the result is IO. Clear? So from here, we are going to see four possibilities. This is the possibility of blood group A. This is the possibility of blood group A. This is the possibility of blood group A. And here is the possibility of the blood group O. Means if the mother is A and the father is A, in that case, the possibility could be A and O both. In the case of children. in the case of children. A and O both. A and O both. This is the way that we are supposed to determine the means we are not exactly doing it's all natural and so this is the way how the blood group of the baby is determined. The blood group of the baby is determined. Fine? Clear? Fine. So I hope you understand. I hope you understand. And if yes, so please, I am just mentioning here the second case, and you please let me know. You please respond me, let me know the example, the second example. I am just mentioning here. Please let me know case number 2. Mother is A, father is B. Mother is A and father is B. So please let me know possibilities. Please let me know the possibilities. Let me know possibilities. If mother is A and the father is O, any one of you, please, I am requesting everyone, please let me know the possibilities. I am just waiting for the response. Mother is A and the father is B. Mother is A and the father is B. Please let me know. I'm just writing this statement on the next paper, next page. Ajay, case number 2. Mother A and father B. A means IA, IO, so IB, IO. So here we are going to see 4 possibilities. Right? We are going to see 4 possibilities. This cross with this. It's the IA, IB. This cross with this. IA, IO. This cross with this. IB, IO. And this cross with this. It's the IO, IO. Yes, right? So here, this possibility is what? It's the AB, A, B, and O. All 4 possibilities. All 4 possibilities. Yes, so this is the way blood is determined. So by doing this entire exercise, you'll be able to determine blood group of the baby. Yes, this is the only way the blood of the baby is determined. Right? You got my point? You got my point, everyone? How this blood is determined? Are you able to understand? Yes or no? Waiting for your response. Right. Right. So now this is what? This is the first part of the blood as the genetics of the blood. This is the first part of the blood as genetics of the blood. How the blood genetics is decided. How the blood group is determined, that we have done so far. Is that clear? Now, the second part of this discussion. Let me take here the second part of the discussion. The second part of the discussion. The second part of the discussion. This people are quite impatient. They are seem to be impatient. Just wait. Let me complete the entire blood. Challenging everyone. You are not going to ask me a single question. Right? So don't be panicked. Let me complete. Yeah, so probably this is the space for the video picture. So, in the same blood, there's a concept of IS factor. IS factor means rhesus protein. Rhesus protein. Rhesus protein. IS factor, that is the rhesus protein. This is also controlled by gene. This is also controlled by gene. Yes, gene for the IS factor. If the gene for the IS factor is present, it means it is positive, or it is absent, it means it is negative. So in the term of genetics, this present, this is also mentioned as dominant, and this absent means this would be absent or hidden. It means it is recessive. It is recessive. Fine. Fine. Okay. So this positive and the negative. Positive and the negative means if the gene is dominant, that make a sense of the positive, means present means it is expressible. That make a sense of the positive, and if it is absent or hidden, that make a sense of the negative. Right? So we have total 4 blood group. Blood group A, blood group B, blood group AB, blood group O. Yes, fine. So blood group A with IS factor is A positive. Without IS factor is A negative. Blood group B with IS factor is B positive. Without IS factor is B negative. Blood group AB with IS factor is positive. Without IS factor is negative. With IS factor is positive. Without IS factor is negative. So any blood group is either positive or negative, is because of the presence or absence or dominant or recessive nature of gene for IS factor, and the IS factor is technically protein. That protein is called as the rhesus protein. That technique is that is what it's a rhesus protein. So the blood group is positive or negative. Blood group is positive or negative. This is because of the presence or absence of RH factor. This is presence or absence of the RH, right? Presence or absence of the RH factor, right? So I hope you understand. A positive means with RH factor with rhesus protein. A negative without rhesus protein. B positive with rhesus protein without. B negative without rhesus protein. AB positive, O positive with rhesus protein. AB negative, O negative without rhesus protein. Okay, fine. Okay. So see here again, 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 again. If I see here now, this gene exists in two alternate forms. One form and second form. And when gene exists in two forms, where one form is dominant while second form is recessive. So these two alternate forms are called as allele. Allele. So allele is technically alternate form of gene. Allele is technically alternate form of gene. Allele is technically alternate form of gene, and gene usually exists in, right? Gene usually exists in two alternative forms, where the one form is the dominant form, but the second form is recessive form. So this concept is applicable to all gene, right? Normally, gene exists in the alternative forms, where one form is the dominant and the second form is the recessive forms. Fine. So the question from the Smita, is it advantageous if a person has RH factor positive? That doesn't make any sense, because it's a natural. If any person has RH protein, that as compared to the second one, means that person means the other does not have RH factor, so it is not going to give you value addition, like you have more vigorous or you have something additional which is not there in the case of the person who has RH negative, because it's a natural. It's a natural, right? And anything is naturally present or absent. It is just because of the adaptation, right? So we are not doing anything. Rather, it is completely evolutionary. So as per the evolution, if any gene is not going to be express itself in the normal course, that does not make us